so sailor out in the lake sees two lighthouses 11 meters apart. So there's lighthouse 1 and lighthouse 2, and they're exactly 11 meters apart. Okay, and we have the relationship, the relative position described in bearing. Okay, so it says here 285 from where the sailor is. So 285, so this is 0, this is 180, 270, 270 is here, 285, so 15 up this way. This is where A is. Okay, and 237 for lighthouse B. So this is 180, right? This is 275. 38 degrees. Okay, so this rotation here is 237, and this rotation is 285. And the distance between these two, okay, is 11. And from lighthouse B to lighthouse A, there's a bearing of 45. Okay, so that means A is more towards this way, right? Instead of there. Okay, like here. Right, so that still has a 285, but A is here. Okay, and this angle from the vertical, this is 45. Okay, how far to the nearest kilometer is a sailor from both lighthouses? So we're basically looking for this length and this length, okay? Given that this here is 11. Okay. Slightly larger version of what we have drawn here. So this is a sailor, this is B, this is A, right? This here is 45. Okay. Okay, we know that this right here, because it was 285, this is 15. Okay, and we also know that this is 57. Okay, we know that's 57 from the fact that this has a bearing of 237, but this is 180. So 237 minus 180 gives you 57. Okay, so note that this and this is parallel. So combined, 45 plus this angle has to be 57 as well, right? Look at this Z pattern. So this has to be 12 degrees, okay, 12 degrees. Also, then we know this angle too. If this is together 57, right, this has to be 23 degrees, which makes this also a Z pattern here, also 23 degrees. Okay, so we found this angle, we found this angle, we know that this is 11. So we have now enough information to find, let's call this x and y. Okay, x over sine of 12 is going to equal to 11 over sine of 38. .7 kilometers for sailor to the first lighthouse. Okay, and then let's do the second one. Y over sine of, so you got to do 180 minus these two angles, 130. Okay, and we can use the same 11 over sine of, right, 38. Okay, so punching that in the calculator, 13.7 kilometers. Okay, so that's answer to part A. What is the shortest distance to the nearest kilometer from the sailor to the shore? Okay, so that's gonna be, right, here's the shore, right? Here's the sailor. That's gonna be the distance of which, if I drew a line to the shore, I get exactly 90 degrees. Okay, so that's the shortest distance. I'm going to call that D, but note that D over Y is equal to sine over 12. Sorry, sine of 12. We just found y, so d is going to be just 13.7 times by sine of 12. Accurate to second decimal point, 2.85 kilometers. That's the shortest distance from the sailor to the shore.